Okay, let's get into some typical requirements and design considerations. So here is a list of different typical requirements, and then I'll go into examples of how these affect the actual spacecraft design. So earlier we were talking about, juggling the placement of components because certain components need a certain orientation within the spacecraft frame. I know for a lot of you, you have cameras which need to observe an unoccluded view of the Earth, for example. So that requirement would be for the payload to be internally mounted but externally facing, and to have an unoccluded view of the space environment. Certain components require a certain placement within the spacecraft frame. A lot of electronics want to be shielded from radiation, so you'll notice that a placement for electronics is usually within the center of a spacecraft. Just talked about the observing payload. Other requirements are to adhere to the size, the volume, the weight, and the moment of inertia, which is like mass distribution. Other requirements could be if your sensors or instruments need deployables to achieve mission objectives. For example, a lot of magnetometers need to be far away from a spacecraft because the electronics on the spacecraft interfere with magnetometer measurements. So you need to put it on like a very long arm or boom. Other requirements are total mass and size, and then the mechanical interfaces between spacecraft components and the primary structure. So let's look at the Juno spacecraft and talk through some of those requirements. So for components requiring a certain orientation within the spacecraft frame, facing away from the spacecraft center, for example, are a suite of instruments. So you'll see spectrometers, the Juno cam, the Jovian infrared auroral mapper, the stellar compass, which is here, and the communication subsystem. All of those components need to be within a certain orientation. So the solar panels need to face towards the sun, the antenna needs to face towards the Earth, the spectrometer, the camera, and the auroral mapper needs to face outward from the spacecraft. The stellar compass needs to face, you see how it's pointing away from the solar panels in the opposite direction? So there's that juggling action happening. Components requiring a certain placement within the spacecraft frame. Like we were talking about just earlier, the magnetometer is far away from the main spacecraft body. The internal electronics are embedded within that chassis. So is the battery. Then we need to talk about the observing payloads. They have an unobstructed view into the space environment. And then let's talk about size for this spacecraft in particular. It had to fit within this Atlas V rocket, where the payload fairing is at the very top. This rocket has a payload fairing available in 2 diameters. It is available in a 4.2 meter or a 14-foot diameter fairing, and a 5.4 meter or 18-foot diameter fairing. So this spacecraft, as is right now, wouldn't be able to fit within this payload fairing. It had to be in some stowed configuration, and then the solar panels and other, like maybe the antenna dish, could then be deployed. So yeah, it would be up to the structure's subsystem to figure out how the collapsed version of the spacecraft and the deployed version of the spacecraft works, and how to transition between those 2 configurations. The Artemis CubeSat kit let's take a look as to how the same requirements affect the design. So the camera needs an unobstructed view. It is looking outward, and for our frame, we designed this aperture hole so that there can be as much unobstructed view as possible. So we milled out a huge chunk of this face. I think this diagram is not reflective or representative of a good mission, because that view is occluded by this panel with the antenna. So I think really this antenna should be on the bottom face. Let's see, there are electronics that are buried in the center, especially the onboard computer. As you'll see in your structures lab, the center of mass is within 2 centimeters, and the CubeSat mass is definitely below 1.33 kilograms. I think there was like a 600 gram margin. So yeah, requirements, ultimate design. Please, in your mission, adhere to these same requirements, because we designed a little bit of flexibility for you to modify and still adhere to the requirements.